Okay. So when we start a research process, so सबसे पहले हम लोग research problem के basis पे we frame some questions that these are the questions for which we are looking for answers through our research. Okay, so like for example, yes, I think yesterday or otherwise we were discussing on one. Suppose we want to do a research on um, effect of birth order on a person's personality. Okay, birth order क्या होता है? Like eldest child, youngest child, only child, middle child of the family, उन्हें हम birth order कहते हैं. So उसका क्या हमारी personality पे effect होता है? So that is what we have to find out. So our question is, suppose, is there any significant impact of birth order on a person's personality? Okay. So हमेशा याद रखो, this question has to be answered in the form of assumption, which will at the end of the research will be proved either true or false. So that assumption, that is assumed answer of these research questions, is known as hypothesis. So our hypothesis, once it is framed, it can be tested using different ways. So depending upon what type of data you are having, you select which type of testing can be done. So there are 4 different types of scales which we have studied: nominal scale, ordinal scale, interval scale, and ratio scale. In case of nominal and ordinal scale, the numbers which are given over there, they are not truly numeric. So what happens is that we cannot find mean and higher order statistical values in such kind of data. So उसके लिए जिस टाइप के डेटा में हम मीन कैलकुलेट नहीं कर सकते, उस टाइप के डेटा के लिए जो हाइपोथेसिस टेस्टिंग टेक्निक यूज होता है. 1 second, guys, just 1 minute. So based on what type of data we are having, our hypothesis testing technique. See, hypothesis testing का मतलब क्या होता है? जो हमने इनिशियली हाइपोथेसिस यानी assumptions फ्रेम किए हैं, उसको टेस्ट करना कि वो ट्रू है कि नहीं है, एक्सेप्टेबल है कि नहीं है, that is known as hypothesis testing. So it is of 2 types. Okay, first is non-parametric. Okay, non-parametric यानी the data from which you cannot calculate values like mean. Obviously, when you cannot calculate mean, we cannot calculate standard deviation, etc. So these higher order statistical values cannot be calculated. So उस type के data के लिए we use non-parametric testing. And we have also already learned about chi-square testing, which is a type of non-parametric testing. So chi-square testing के case में we just require frequency of observation. यानी कोई भी phenomena कितनी बार हुआ है, how much, mean, median, that is not required. So we all remember the formula for hypothesis testing using chi-square is, it is summation of, just 1 second. The formula is, chi-square equals to summation of observed frequency minus expected frequency whole square upon FE, right? So this part we have already done, and we have done a couple of sums also on that, and we have recorded the solutions. So if in case you're forgetting it, you can see the recording, and I've also uploaded a PPT material. So you can see that PPTs also, that will help you in remembering it again. So another set of testing technique is known as parametric tests. Okay. In case of parametric test, guys, you need to have parametric values. Parametric values यानी population mean, standard deviation, etc. ये सारी चीजें होनी चाहिए. इस केस में ये not possible होती हैं. और इस केस में ये सारी चीजें अगर हमारे पास डेटा के साथ में अवेलेबल हैं, so we can use parametric test. So the most common parametric tests are Z and T test. Okay. So just 1 minute. We can write it this way after changing the color. So we have 2 types of tests which are very popular, which are Z and T test. Now, how do we know that which test has to be applied? Okay. So from Z and T test, first of all, please remember, for any of these parametric tests, to be conducted, one thing which we require compulsorily for any test, Z or T or anyone. So in that case, we require one thing, and that is known as population mean. Okay, which is represented by mu. Okay, so that has to be there. Otherwise, you cannot conduct any of the parametric test. Now, in what situation would we conduct Z test, and in what situation we would conduct T test? For Z test, the first condition is जिस सैंपल आपने लिया है, पॉपुलेशन में जो आप सैंपल निकालते हैं, वो जो सैंपल लिया है, उस सैंपल का साइज 30 या 30 से अबव होना चाहिए. ओके, अगर सैंपल का साइज 30 से अबव नहीं है, 30 से कम है, so then in that case you have to go for T test. And the second thing which is required in the formula of Z test is that is standard deviation of population. Okay, which is represented by sigma p. और इस केस में स्टैंडर्ड डिविएशन ऑफ द पॉपुलेशन नहीं भी है तो भी चलेगा, बट पॉपुलेशन मीन तो दोनों केसेस में हमें चाहिए ही चाहिए. ओके, सो विद दैट टुडे वी विल स्टार्ट विद Z and T test analysis properly. And before we start, I'll just see which all sums we have already done. We'll not repeat that. We'll take fresh sum to solve. Okay. Okay. So now, is this clear? Up till here, is it clear? Okay. So first of all, when we talk about population, okay, population size, that means number of elements in the population is represented by capital N, while in case of sample, the sample size is represented by small n. Okay. Population mean is represented by mu. At times, even standard mean is represented, जिससे हमें sample का mean compare करना है, that is represented by mu. Mu, it is MEW, and the sample mean is represented by x bar. Okay, x square nahi, x bar. Okay, standard deviation of population is represented by sigma p, and standard deviation of the sample is represented by sigma s. Okay, so let us now see what are the formula for Z and T test. Okay, we'll write it for Z test first, and then we'll go for T test for then. Okay, in case of Z test, guys, there can be two situations. One, when the population size is not known to us. Like, for example, we want to talk about how many people, travel through, our Eastern Expressway every day. So that we cannot know. So sometimes the population size is not known. Okay. So in such cases, the population is said to be infinite population. Okay. That means we do not know the population size. Population size का symbol क्या था? N. So N is not known to us. Okay. So in such cases, we use infinite population formula for Z. So Z is equal to, in such cases, mean of sample minus mean of population divided by standard deviation of the population upon square root of sample size. Okay. इस केस में हमें population size पता ही नहीं है, तो population size को हम use ही नहीं करेंगे. Now, for example, now you know specifically what is the population size. Suppose आपसे पूछा गया कि how many students are there in the college. So you know the population size is 2,526. Okay. So we know the population size. When we know the population size, we call it as finite population. That means, इसका मतलब क्या है कि capital N यानी population size is known to us. Okay. So in such cases, the formula becomes little more precise. That is, apart from this formula, which is for infinite population, we have to multiply one more thing. Okay, this is the formula for infinite population. We have to multiply it by square root of capital N, that is population size minus sample size upon population size minus 1. Okay, so this is the formula for finite population. Finite population means what? You know the population size. Infinite population means what? You do not know the population size. Now, similarly, when we talk about t-test, first of all, we all know z-test is applied when the sample size is greater than or equal to 30. And we also have standard deviation of the population. Okay. T-test is applied. First of all, sample size. Small n is what? Sample size. Sample size is less than 30 and standard deviation may not be known to us. If it is known, we will make a use of it. Otherwise, we will calculate it. So now again, in this case, the first case is if the population size is infinite. That means we do not know the population size. That means capital N is not known. Okay. So in this case, the formula is similar to Z, but only instead of sigma P, we put sigma S. That is standard deviation of the sample. So formula is same. Mean of the sample minus mean of the population upon standard deviation of the sample divided by square root of sample size. Okay. Now, again, the second case is if the population is finite. So what do you mean by, what is the meaning of finite population? Anyone? What do you mean by finite population?
Limited, specific.
Yeah, population size is known to us. Specific population size is given to us. Yes. So in this case, again, like z-test, we will add the same, multiply the same factor here. So इस case में भी first part तो same ही रहेगा. And then we are going to add this. It is for finite population where capital N is the population size and small n is the sample size. Okay. So this is the formula for finite population for t-test. So in case it is required, if you have your notebook, I request everyone to please write it down in your notebook or at least take the screenshot of it. Once you are done with that, we can start with solving the sum based on these things. See, अगर जैसे हमारे पास एक क्वेश्चन है कि लास्ट मंथ हमारे जो कस्टमर्स हैं उनको बिलिंग में 10 मिनट्स लगते थे. ओके. और अदरवाइज ऑन एन एवरेज 11 मिनट्स लगते हैं या 12 मिनट्स लगते हैं. ओके. सो सपोज आपको ऐसी सिचुएशन दी गई है कि यू जस्ट हैव टू फाइंड आउट कि ओके, आई विल गिव यू अनदर एग्जांपल. ओके. Suppose the question is, our customers take 12 minutes to complete the billing process. Okay. So has the process changed? फिर आपको एक सैंपल दिया जाएगा 10 दिन का कि इन 10 दिनों में या 10 कस्टमर्स का कि इन 10 कस्टमर्स को 12, 13, 10, 11 ऐसे अलग अलग टाइम लगा बिलिंग के लिए. So आपका क्वेश्चन ये है, is the billing time same or different as compared to 12 minutes? 12 minutes स्टैंडर्ड टाइम है आपके शोरूम का बिलिंग के टाइम के लिए. ओके. बट आपने 10 दिन का एक सैंपल लिया है और आपका ये क्वेश्चन है कि ये जो सैंपल का एवरेज टाइम है, is it similar to 12 minutes or is it different from 12 minutes? So when I say is it different or is it not similar, so means whether the time has changed or not. The change can be, when I say change, the change can be both positive and negative. So when there is a situation where the change can happen in both positive and negative direction, that means it's not specified कि change ज़्यादा में ही होगा या कम में ही होगा, then in that case we go for two-tailed test. Okay, we will see the example so that it is clarified. So in case of two-tailed test, suppose the level of significance which is given to us is 5%. Okay. So in case of two-tailed test, this 5% will get divided into two rejection areas on both the sides. Because value can be greater than 0 or less than, significantly less than 0 or significantly greater than 0. So in such cases, we have to have rejection area on both the sides. So this 5% will get divided into 2.5% here and 2.5% here. Okay. So when we convert 2.5% in decimals, what will happen? It is 0.025 here and 0.025 value of alpha here. So rejection area will get distributed in two different directions. Okay. Now there is another sum. Suppose I have a bulb manufacturing factory. Okay. And I have brought new machines with latest technology. So I'm thinking because of this, you know, the life of the bulbs will increase. Okay. So suppose otherwise जो मेरे bulbs बनते थे यहाँ पे मेरी factory में, उनकी life होती थी 24 months. That means 2 years. Okay. But because of new technology, I think the life has increased. So what I'll do is, suppose मैंने 10 bulbs का एक sample लिया और उनकी life को count किया. तो किसी का 22 आ रहा था, किसी का 25 आ रहा था, किसी का 26, किसी का 24, किसी का 30, किसी का 28, okay, और किसी का 27. So इस तरह से 10 bulbs का मैंने लिया. तो my question is, has the life of the bulb significantly increased or not? That means I'm just interested to know whether the life of the bulb has increased or not. That means I'm just interested to know whether the change has happened in the positive direction or not. So in such cases, when in the question itself, it is mentioned that we have to find whether the whether the outcome has increased or it has decreased. So in such cases, we clearly use one-tailed test. Okay. That means our entire level of significance, that means our rejection area will fall in one direction only. So that is known as one-tailed test. So in this case, if 5% is level of significance, so 5% will fall in one side only. Okay, so that is known as one-tailed test. Okay. Now, a company manufacturing car tire finds that the tire life is normally distributed with a mean of 40,000 kilometers. So what all is given here? First of all, population mean or standard mean is given. That is 40,000 kilometer. And the standard deviation is 3,000 kilometer because it is still talking about the population. So standard deviation of the population is 3,000 kilometers. It is believed that modification in the process will result into better new tires. Okay. So a sample of 64 new tires were selected. So sample size kitna hai? 64. Okay. It was selected. And the company has found that the mean life of the new tires is 41,200. So इस sample से उनको क्या पता है? Sample का mean कितना आया? 41,200 kilometers. Okay. So this is the sample mean. Okay. Can it be concluded that the new tire is significantly better than old? यानी significantly better कब होगा? When जो ये standard इसका life था, उससे better, significantly better उसका life है. Okay. किसका? New process वाले टायर का. At what percent we have to check? Alpha का value क्या है? 5% we have to check. Okay. Now guys, अब इसमें हमें काफी सारे questions का सबसे पहले based on this we have to find out that what are we supposed to do with it. Okay. Okay. So first of all, our question is, पहला question है, is it a Z-test question or T-test question? Second question is it, are we going to use infinite population formula or finite population formula? And the third most important question is it a one-tailed test or two-tailed test? Okay. Now, first of all, To find out whether it's a z-test or t-test, let us look into the sample size. If the sample size is greater than or equal to 30, we go for z-test. Okay. Otherwise, if the sample size is less than 30, we go for t-test. So can anyone help me? Are we going to have z-test or t-test?
Z.
Z. Okay. So first problem solved, z-test. Correct. Next is whether it's an infinite population or finite population. Finite population means what? We are having specific population size. Are we having it here? No, it has not talked about 40,000 kitne tires ka average hai. No, na. So nothing like, population size has been mentioned in the question. So we say that population size is not known. So hence we will go for infinite population formula. Now the next question is whether it's a one-tailed test or a two-tailed test. Okay, so in such cases, please remember the question asked is we have to find out whether the life of the tire has significantly increased or not. That means the tire has become better or not. So they are just bothered to understand whether it has significantly increased or not. Okay, so in this case, what do you think? What test is it? Is it one-tailed test or two-tailed? Are they asking whether the life of the tire or tire has changed in any direction? Life has changed, or they're specifically asking the life has increased or not? So what do you think? It's a one-tailed test or a two-tailed test?
Two-tailed.
No, if they had asked
One-tailed.
Yeah, if they had asked whether the life of the tire has changed or not. So change could have happened in any direction, right? The change could have been in positive as well as in negative direction. Okay, but now they're specifically asking, has the tire become better? That means whether the life of the tire has increased or not. They're not bothered anything else. They would just want to find out whether it has increased or not. So significant difference हमें किस साइड में निकालना है कि significantly increase हुआ है कि नहीं हुआ है. So our test will be, can you try it once again? What test will it be? I think Ujjwal was responding to it. Ujjwal and Janam.
One-tailed.
Yeah, it is one-tailed because they're clearly asking whether it has become better or not. That means whether the life has increased or not. So that is why it is one-tailed test. Okay. So we have concluded A, it's a z-test. B, infinite population. 3, one-tailed test. And don't worry, we'll practice few more things and you'll be able to easily recognize whether it's a one-tailed test or a two-tailed test. Okay. We'll take a lot of other samples of only hypothesis. We'll frame only hypothesis, whether it is one-tailed or two-tailed. Okay. So yeah. Okay. So actually, technically, the first thing what we should do is we have to find out, we have to frame the hypothesis in this case. Okay. So suppose for z-test, there we have to frame null and alternate hypothesis. Guys, in case of parametric test, it is always suggested you begin with alternative hypothesis. Okay. Now, suppose there are two numbers, x and y. Okay. There can be 3 different types of relation between two numbers, either equal to or greater than or less than. Okay. So, idhar hamara question kya hai? Is the new mean significantly greater than mu? That means, is x bar significantly greater than mu or not? Okay, so greater than sign, whatever has been asked should be written in alternative hypothesis. Okay, so we can say x bar is significantly greater than mu. If you want to write in the form of equation or inequation, it is x bar is greater than mu. That is alternate hypothesis. Null hypothesis, see, this condition has been given to alternate hypothesis. What are the two conditions left? Less than, equal to. So these two conditions will be used in null hypothesis. So X bar is less than or equal to mu. So if the value or life of the new tires has significantly increased, obviously your H null will get rejected and H1 will be accepted. Okay. So one second. Now we'll try solving this sum. But before that, we have to find out the table value of Z. I'll just show you how the table looks like. I'll just frame the table using the most frequently used level of significance. So from that, we will find out the table value of Z. Okay, for table value of Z, guys, we require two things. That is alpha, that is level of significance, and whether it's a one-tailed test or two-tailed test. Only these two things are required. In this case, degree of freedom doesn't matter. Okay, so alpha is already given to us, that is 5%. 5% means what? 5%, 5 upon 100, which becomes 0.05. So that's the value of alpha. And we have already found out that it's a one-tailed test. So we will find for the value of alpha for one-tailed test, what is the table value? Let us quickly see that. I've already written a lot. Let me see whether the table is visible or not. Yeah, the table is not visible. Anyways, so for 5% level of significance for one-tailed test, the table value is 1.645. So how does it look like? Because it's a one-tailed test, we will have rejection area only in positive side. Sometimes this type of one-tailed test where the rejection area is only on positive side is also known as right-tailed test. Okay, because the rejection area is in right side. The tail having rejection area is in right side, is on right side. So ideal value will be Z equals to 0. And the table value will be plus 1.645. Why plus? Because it is on the positive side. Why agar hum question lete whether the value has decreased or not, they would have come in the negative side, that is minus 1.645. Okay, so this is what we have to find out, whether the calculated value is falling within this region or is it falling in this region. Okay, if it is falling within this region, that means value is between 0 and 1.645. We will say that the value is not significantly high and hence we will accept null hypothesis. Okay, but if it falls beyond 1.645, agar calculated Z की value 1.645 से ज़्यादा आती है, so we have to reject null hypothesis because it is significantly higher. Okay, so let us see. Let us go back to our slide and see how to solve that sum. Blank slide, blank slide. Yeah, here it is. Okay, so now we will substitute the values in the formula of Z test for infinite population. What's the formula? Z is equal to X bar minus mu upon sigma P upon square root of small m. I will substitute the value. You guys have to quickly calculate what is this value of Z. This is Z calculated value. Okay. So X bar is 41,200. Mu is 40,000. Sigma P is 3,000 upon square root of small n, that is 64. Can you guys quickly help me with the answer? Okay. So we found that the calculated value of Z is 3.2. Okay. So we'll just write it properly. Calculated value of Z is 3.2. Okay. And table value kitna aaya hai? 1.645. Okay. Z table value is 1.645. Okay. Now, guys, can you tell me, would we be rejecting null hypothesis or accepting null hypothesis? Any idea? We will be rejecting because the table value is lesser than the calculated value. In fact, we reject null hypothesis. I've stated that earlier also, when the calculated value is higher than the table value. Okay. So now in this case, if it is 3.2, it will fall somewhere over here. That is 3.2. That is basically in the rejection area. So hence we are going to reject null hypothesis. So what if we are rejecting null hypothesis, what are we accepting? The alternate hypothesis. So alternative hypothesis says that X bar is significantly greater than mu. That means the life of new tires are significantly higher than 40,000 kilometers. Am I right? So how do we end this? Interpretation is written like, as the calculated value 3.2 is higher than the table value of Z, that is 1.645, hence we reject the null hypothesis. Conclusion is, therefore, the life of new tire, that is 41,200, is significantly higher than the average height otherwise, that is the general height, that is 40,000 kilometers, or population mean is 40,000 kilometers. So that is the conclusion which we draw from this. Okay.